Hello, my name is Marcos Romero-Suárez, and this work was developed in collaboration with Marta Evelia Aparicio García and Jesús María Alvarado Izquierdo. It's a pleasure to be here today. In this presentation, we'll focus on a multi-method approach to investigating between-group differences in latent variables. Okay, but you're probably wondering how I ended up here, giving an online presentation at a presential congress. Let me explain, step by step. First of all, I'm actually here at the Congress in person, but right now, as you're watching this, I'm in another room, specifically room 11, presenting one of the talks in the symposium Advancing Dynamic Methods for Modeling Change Over Time. Unfortunately, due to a scheduling conflict, I have to record this presentation in advance. I'm telling you all this because if you have any questions, you can find me in room 11. And if you happen to watch this video and later run into the in-person version of me somewhere at the Congress, please tell me. It would be funny. First of all, the method I'm going to present is designed to study differences between groups with a particular twist. These differences are not assessed on observed variables, but on latent variables. In psychology, latent variables typically refer to constructs that are estimated from test items such as cognitive ability, motivation, or anxiety. So, in this presentation, I will walk you through the key steps required to study group differences at the construct level, that is, using latent variables rather than raw scores. This is a multi-method approach that combines several mathematical techniques to reach more robust conclusions. The key idea is that by using multiple tools, we can compensate for the weakness of any one technique. While there is a general conceptual order to follow, this isn't a rigid sequence. You may not need to apply all techniques every time, and you can also add complementary methods if relevant. Compared to relying on just one analysis, this approach tends to be more reliable and complete, and in general is quite robust. That said, it's important to be clear about what this method is not. It's not infallible. No method is. It's also not purely data-driven, although data-driven diagnostics are key. Theoretical reasoning should guide our decisions when possible. And it's not purely theory-based either. Empirical evidence matters. Ultimately, it's not a rigid recipe, but a flexible, integrated framework for making more informed decisions. So, let me walk you through the steps of this multi-method approach. This approach is built around three core questions. First, am I measuring well? Second, can I compare groups? And finally, what are the actual differences between those groups? Okay, first, measuring well, second, compare groups, and finally, differences between groups. We begin with a basic but fundamental step, assessing the dimensionality of the test or scale. How many factors are we really capturing? What's the underlying structure? Then, to check if this structure is robust, we use bootstrap-based exploratory methods. Okay, bootstrap-based exploratory methods. This helps us to evaluate the stability of the dimensionality across samples. It's a simple idea. Once we identify a plausible and stable structure, we move on to confirmatory factor analysis, where we test how well that model actually fits the data. If the model fits well, we proceed to test measurement invariance. This tells us whether the structure holds across different groups. It's a key step before making any comparison, and that's so important. Finally, if invariance holds, we can compare groups meaningfully and interpret any observed differences, knowing we're measuring the same thing in the same way. Let's take a look at the data I used to illustrate this method. The sample included 837 men, aged between 18 and 64 years. Because the age distribution was highly positively skewed, and based on the concept of emerging adulthood, I divided the sample into two age groups, using the median age of 26, which also represents the change between early and late adulthood, as the cutoff. This gave me 439 participants in group 1, 26 or younger, and 398 in group 2, over 26. In the table on the right, we can see the test used to measure masculinity, the CMNI 29, which is made up of 8 subscales. For example, the description of self-reliance, that is a factor, would be aversion to asking for assistance. And an example item would be, I hate asking for help. 1. Dimensionality assessment. To start the dimensionality analysis, we used two types of parallel analysis. The first is PA based on principal component analysis, which is generally recommended when the factors are expected to be weakly correlated. The second is PA based on principal axis factoring, which tends to work better when the factors are highly correlated. On the left, you can see the results from the PA-PCA method. It suggests solutions with 8 factors. In this case, that might be more appropriate method, since low correlations between factors are expected theoretically for this test. And on the right, we have the results from PAF, which suggest 9 factors instead. Now let's take a look at what exploratory graph analysis, or EGA, tells us. Broadly speaking, EGA is a psychometric network technique based on partial correlation. It applies some adjustment to remove spurious connections and then use clustering to identify groups of items. The result is an exploratory model that not only estimates the number of dimensions but also indicates which items belong to which factors. In this case, EGA suggests an 8-factor solution and largely recovers the underlying theoretical structure, except for items 5 and 12. These two are placed under the violence factor, even though, theoretically, they belong to heterosexual self-presentation. However, given their spatial proximity in the network, this misclassification likely refers cross-loadings, meaning these items have meaningful associations with both factors. We'll revisit this issue later. But for now, the main takeaway is that the 8-factor solution matches the theoretical model quite well, which gives us confidence in the dimensionality. 2. Bootstrap exploratory methods to enhance dimensionality stability. When we apply Bootstrap EGA, we find that the main replicability issues are indeed linked to items 5 and 12. This suggests that the factor assignment from the original EGA is not entirely stable. In contrast, Bootstrap EFA reveals cross-loadings involving the violence factor. However, the highest loadings still correspond to the item's theoretical factor. Considering these results, along with the content of the two items, it seems reasonable to attribute the cross-loadings to sampling variability. Therefore, we believe it's appropriate to retain the original theoretical structure for now, though this should definitely be considered in future applications or revision of the instruments. 3. Confirmatory factor analysis and model fit. This is the model we decided to analyze using CFA, which also aligns with the theoretical structure. Here we can see the correlations between factors, which are indeed low. This helps explain why PA-PCA outperformed PA-PAF in earlier steps. We also see the item loadings and overall fit indices for the model. Most indices suggest a good fit. The only concern is RMSEA, which shows slightly problematic values, likely due to the cross-loadings we identified earlier. Overall, though, the model performs well, and we can conclude that the test provides a solid measurement of the intended constructs. 4. Testing measurement invariance. To ensure valid comparisons between groups, we tested measurement invariance, verifying that the construct emerges in the same way across both H groups. This includes invariance in the factor structure, item loadings, and potential baseline biases. Since the items are categorical, we also tested threshold invariance. This step assumes that responses reflect threshold on an underlying continuous normally distributed latent rate, and that these thresholds manifest similarly across groups. We assessed invariance using common criteria such as changes in CFI and also RMCA-D, a less commonly used index that considers a change above 0.06 as evidence of non-invariance. We found evidence of invariance at all levels, but for intercepts, the change in CFI supported invariance, while RMCA-D was right at the 0.06 cutoff. Given that these cutoffs are guidelines rather than strict rules, and CFI supported invariance, we concluded that measurement invariance holds between the two age groups. 5. Differences between groups. Okay. The test is psychometrically sound and the group comparisons are meaningful. We proceeded to quantify the differences between groups. To do this, we ran one regression per factor, using each group as the independent variable and each latent factor as the dependent variable. The key idea here is to predict latent scores. Something can be done either through structural equation modeling or by extracting factor scores from the measurement model. The beta coefficient directly represents group differences. This coefficient indicates not only the direction of the difference, but also its magnitude in standard deviation units. Here we can see the results, showing differences in masculinity across the dimensions of winning, risk-taking, violence, self-reliance, heterosexual self-presentation. All of these factors show a decrease in average masculinity when comparing younger adults to older adults. Thanks to this procedure, we ensure that our measurements are valid, the group comparisons are appropriate, and that any differences are assessed more rigorously, directly at the level of the latent variable. And that's all. Thank you very much. I hope I didn't sound too robotic because I hate recording myself. Feel free to add me on LinkedIn or contact me by email if you want to get in touch. And stay tuned because soon an article will be published where I will explain all of this in greater depth and detail. And any questions? Don't know. Bye bye. Okay. No one has any questions? I hope you like it. Bye bye.